record the session and we'll move right. Okay. So, in our last class, we have seen about simplifying K-map, right? Using the sum of product method. Right? Sum of products means we will have a Boolean function like a dot p dot c plus a bar dot p bar dot c, something like that. Right? In this class, we are going to see about the product of sum terms or the max terms, right? Product of sum terms. Or simply we can say it as POS terms, right? POS. Right? So POS is nothing but, yeah, we'll start with an example, right? So just consider the truth table, right? With two variables, set A, B, and Y, right? 0, 0, 0, 1, 1, 0, 1, 1, right? So let this be 1, 1, 1, 0, and 1, right? What we have done earlier is we have grouped the ones. Right, we have another choice, right? We have another way of doing this one, right? For example, if f of a comma b, we can write it as by grouping the ones, right? Right, so there's 1, 2, 3, right? So this will be a bar b bar plus a bar b plus a b. Right? Yeah. So, but we can do this one in another way as well, right? So just consider the 0 here. Right? So the f of AB can be written as, right? So we can write this as A B bar whole bar. Am I right? So we can write it y or f of AB as A B bar whole bar, right? If we apply the De Morgan's theorem, we can write this as A bar plus B. Right? If we apply De Morgan's theorem here, we can write this as A bar plus B, and this is called as the product of sum terms, right? For example, consider another truth table, right? Yeah, for example, if we have this one 0, right? So our truth table or our new y will be, or let this be y dash, will be A B bar plus A B whole bar. Am I right? So we can rewrite this as A bar plus B double bar becomes B, right? So plus becomes dot, and A bar plus B bar or A bar or B bar, right? So this is called as the product of sum or POS, right? You can see that this is a sum term, right? And the equation is in the form of product of two sum terms, right? So these are called as POS or product of sum terms, right? This will be easy when you are doing some kind of Boolean equations, right? So in this class, we are going to see how we can simplify Boolean equations using POS terms, and how we can use K-map to simplify the Boolean equations, right? Before going into that, I just want to recall about a couple of the rules we have seen earlier, right? So the first one is actually, so we have seen, right? So what is A plus 1? A plus 1 will be 1, and A plus 0 will be A. As I said, A plus A will be A, and A plus A bar will be 1, right? If A is 1, A bar is 0. If A is 0, A bar will be 1. So 0 plus 1 or 1 plus 0, both will give you 1, right? Meantime, we have another law called distributive law, A plus B into A plus C, right? So simply we can do this one, right? So you can remove the bracket by using by considering this as a simple binary equations. So A dot A plus A dot C plus B dot A plus B dot C. Am I right? So I can write this as, right? So A plus AC plus AB plus BC. Am I right? So because A dot A becomes 1. Oh, sorry, A dot A is A, right? So A into 1 plus C plus B plus BC. So this can be written as A plus BC, right? For example, you have A as the common term, which is written here, and the multiple of the second terms in the equation, right? So this can be applied for any term, right? For example, A plus B plus C into A plus B plus C bar, right? You can consider the A plus B as capital X, right? This as X. So this is in the form of X plus C bar, which is A plus B, A plus C. So we can write this equation as A plus B into, sorry, A plus C bar. C bar becomes 0, right? Because if C is 1, C bar 0. If C is 0, C bar becomes 1. Right? So we can write this as A plus B. Right? So let's see. Consider, okay, we'll move for another example, right? With 3 variable truth table. Yeah, consider truth table with A, B, C, and Y, right? 0, 0, 0, 0, 0, 1, 0, 1, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, and 1, 1, 1. Right? So let the output as 0, 0, yeah, all the others are 1. Right, so we'll try to solve this one using POS method, right, or POS method, the product of sum. Right, so what we have to do first is we have to identify the zeros, right? So we have in the earlier we have grouped the ones, so we have choose the ones, but now we have to identify the zeros there, right? So here we can write 0, 0, 0, 0, 0, 1. Right? If in simple terms, we can write Y as A bar, B bar, C bar plus A bar, B bar, C whole bar. Am I right? So we can write the equation as A double bar becomes A plus, oh sorry, A bar, B bar, C bar whole bar dot A bar, B bar, C whole, right? So we can rewrite this as, again, right? So now A double bar becomes A plus B double bar becomes B and C, right? Dot A plus B plus C bar, right? So if we want to do this one directly, what we can do is, right, while we are simplifying this one, right, in normal terms, what we have done is we have put 0 as bar and 1 as the director, right? But when you are processing, when you are using the POS terms, you can use A as 0 and A bar as 1, right? So you can directly apply this one and you can use the POS term. For example, if you want to write y equals a is 0, which means a, 0 means a, right? So we can do it as a plus, again, b is 0, which means b, then c is 0, which means c, right? Into, again, a, b, both are 0 and c is 1, right? So a plus b plus c bar. Now you can apply the distributive law. As I said, consider a plus b as capital X, so capital A whatever, and then c plus c bar. So you can write this as a plus b into, plus c bar. C bar is 0, so a plus 0 becomes a plus b. Right, so this is the simple way of doing POS. Right, now let's see how we can use this one or how we can simplify these things using a K-map, right? For example, we'll do the same thing, right? We'll apply the K-map technique for the same truth table. Right, I think you all can hear me, right? Okay. Right, so as I said, there are 3 variable K-map, right? There are 3 variable K-map, so we need 8 boxes as we have seen earlier. So let A here, B and C will go to the 2 stage, right? A 0 and 1, so this will be 0 0 0 1 1 1 and 1 0. You all know why we have this 1 1 next to 0 1, right? Because only one variable must be changing when you are doing a pair, right? So if it is 1 0, then 0 becomes 1 and 1 becomes 0, so the grouping is not possible, right? To make the grouping possible, we use the order like this, right? If we write the decimal equivalent numbers, we can simply write this as 0 1, this will be 2 3 sorry 4 5 and 6 7, right? You can see the letters, right? So first represent the zeros there, right? So this one and this one, all the others are 1 1 1 1 1, right? So if you want to do POS simplification, of course there are 2 zeros and you can make a pair here, right? You can make a pair here, right? The naming, here comes the trick, right? So earlier we have used, right, for these two, a bar, right, a0, right, is common for both, right? Earlier, if the common value is 0, we used the same a bar, right? But here in this technique, we are going to use, if a is 0, we are going to use a, right? If the a value is 1, then we will be using a bar, right? So here for these two, a0 is common and b and c, you can see that c is 0 and c is 1, right? So it becomes c bar plus c, right? C bar plus c, then both, if you're adding, then that will become 0, or you can be eliminate that one. So the common value is b and the value of b is 0. So you can simply write your y as, right, a plus b, right? So what you are doing here is you are grouping the zeros and you are inverting the values what you are having in the direct K-map reading, right? So double bar becomes simply eliminated, right? Y double bar becomes y. That's what the principle behind this one, right? So that's all about the simple introduction on POS techniques. Yeah, we can try an example, right? We can try an example. Can you share one example with me, please? So the truth table what we have got for okay, I'll give you one example, right? So here we can write this equation as kind of like this, right? So if you have y into POS, we will be writing this as phi of, right? Because we are going to write it as a multipliers, right? So phi of 1, 3, 5, 6, 7, 8, 9, 10, 11, 12, right? If we write this, right, if the equation is given like this, then it means that all these values represent zeros in your K-map, right? Remember, right, in the other term, the values given are represented by ones in your K-map, but when you use a phi, all these values will be represented by 0 in your K-map, right? So let this be y of a, b, c, d, right? So since you have 4 variables, we need a K-map with 16 boxes. Right, this be A, B, and C, D, right? Don't do anything with the order, right? So this will be 0, 0, 0, 1, 1, 1, 1, 0, 0, 0, 0, 1, 1, 1, and 1, 0, right? So what we have to do is, of course, we need to write down the decimal equivalents first, which will be easy for you, right? So I can simply write this as 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and 15. Right? So now we have the K-map. You can easily fill this one, right? You can easily fill the K-map. So what we can do is we have to fill the given numbers as 0, right? So 1 is 0, 3 is 0, 5, 6, 7, 8, 9, 10, 11, and 12. All the others are 1s. Right? So that's all about the K-map. Now we have to group the zeros, right? So of course you can see that, yeah, 1, right? So in this one you can see, yeah, C, D both are changing, right? C 0, 1, so it is not depends on either C or D. But here A is 1 and B is 0, right? So in POS terms, so this becomes A bar plus B, right? Since we have grouped zeros, we have to invert the value what we have in the boxes, right? The second group is this one, right? We can see that there is another quad, right? Another box of 4, and then we will name this one first, right? To this one, you can see that, of course, B is changing, but A is 0, right? So this becomes A plus, right? Since it is 0, we need to write it directly, and then see here, C is changing, C is 0 and 1, but D is a constant and the value of D is 1, hence it becomes D bar. Right, similarly, we have 2 more boxes which I can make them into pairs, right? One is this one, so the name of this will be, right, so A0, B1 is common, right? So I can make it as A plus B bar, and out of these two, right, C is 1, 1 common, but D is changing, so we can eliminate the D, but C is 1, so that becomes C bar. Right, again, I have another pair here, right? I have another pair here. Right, so what I can do is I can simply name this as, of course, C, D, both are 0, right? That is common. And out of these two, look at here, A1 is common, but B is changing, right? We can eliminate B, so this becomes A bar because A value is 1 plus C, D, both are 0, so I can write them directly. D. Right, so the whole equation or the final equation can be written as or your y is equal to A bar plus B, A plus D bar, A plus B bar plus C bar, A bar plus C plus D. Right, so that's all about simplifying a POS equation using K-map. Right, now, if you have any doubts, please let me know, right? Any questions, you can type them in the chat box. Any questions? No questions. Okay, so we can stop with that, right? So that's all about solving the equations or solving the POS